Hello everyone. So in this particular problem I'm going to show you how the magnetic force works on an individual charge. I did a video for the bonus question that was released on Sunday, and in that one I showed you how forces of two wires interact with each other. So on this particular one, what I want to do is just deal with an individual charge, and I also posted up the solution on this outline to the one with two wires. So what we have is we have a charge. Its charge is 3e, and it's given mass, given velocity. It enters this magnetic field. X's denote that the magnetic field is going into the page, and dots denote that it's coming out of the page. So this particular magnetic field is going to be going into the page, and we have 0.15 Teslas. So what this thing is actually going to do, according to the FBI gun law, is as it enters the magnetic field, it'll travel straight. Then once it enters the magnetic field, it's going to begin to curve. And if the magnetic field was big enough, it would just travel in a circle. You can check out using the FBI gun law right-hand rule to confirm that this would definitely go towards the top of the page. But the key thing I want to keep in mind, though, is when we do the summation of forces on this, it does equal ma, but specifically since it is going to travel in a circle, we want the circular acceleration v squared over r. The only force present is the magnetic force, and the magnetic force on an individual particle is qvb sine theta, and that's going to equal mv squared over r. So what I can do now is I can cancel out one of these velocities. The sine of theta, the magnetic field is going into the page and the velocity is to the right, so they're 90 degrees apart. Sine of 90 degrees is 1. Our next step will be to move R over to the left and move the Q and B over to the right. So the radius of the circle that I would end up creating is mv over qb. So m is 1.25, e negative 25, v I got 300,000 meters per second. Q, so 2e, that's 2 times the elementary charge of 1.6 e negative 19. 1.6 e negative 19 is the charge of an electron as well as a proton. Electron being negative, proton being positive. So now that I've gone ahead and set this up, punch it into the calculator. 1.25 e negative 25 times 300,000 divided by the quantity of 2 times 1.6 e negative 19 times 0.15. And the result is we get a pretty small circle here. The radius of the circle is 0.0176 meters, or 1.76 centimeters. There you go. Enjoy the web design.